Hi, I'm Rob and welcome to this, our 19th lesson on the topic of trigonometry. And in this lesson what we're going to take a look at is working with and using the formulas or identities you have access to on page 14 and 15 of your formula booklet. So it's working with those formulas. So this begins in your notes on page 284. And you'll notice on page 284, the first thing we mentioned there are the compound angle formulas. Now, a compound angle is an angle that's formed by adding together or subtracting two other angles. So if you add or subtract two other angles, you get a compound angle. And there are 6 formulas for working with compound angles. You can see them there on page 284. You're given a formula that tells you what cosine A plus B is, sine A plus B, and tan A plus B is. So if you've got two angles added together, there's a formula there for telling you what the sine, cosine, and tan of that compound angle is. Or if you're subtracting one angle from the other, cosine A minus B, sine A minus B, or tan A minus B. So they're the 6 formulas there, and they're all given on page 14 of your formula booklet. You can see there's page 14 of your formula booklet there, and you can see here they are. The sum formulas are here in the top left-hand corner, and the difference formulas are here. Okay, so the 6 formulas that we're mentioning there are all found on page 14 of your formula booklet. And in these questions here, all we're going to have a look at is how you could apply those. Either to simplify an expression or maybe to make solving an equation a little bit easier. So if you look at the first question there on page 285, question 19.1, it says you're given the following extract from page 13 of the formula booklet. So we've got a table there showing you in surd form what the sine, cosine, and tan of the main angles are, the major angles we encounter in trigonometry: 0 degrees, 30 degrees, 45, 60, 90, and 180. And you're asked to find the value of each of the following without using your calculator. Okay, so essentially what I'm asked to do is to use that form there to find these. I'm not just going to type it into my calculator. So you can see the first one there we're asked to find is cosine 15 degrees. Okay, so we're asked to work out what cosine of 15 degrees is in surd form. So the idea here is that what I want to do is I want to use the formula. I want to try to write that 15 as either 2 angles added together or 1 angle subtracted from another. So I can use one of my compound angle formulas on page 14. And there may be more than one way to do that. So for example, if I wanted to, for cosine of 15 degrees, I could write that as 45 minus 30. Because both 45 and 30 are included in the table at the top of the page. So I'd be able to find those in the table. I could also, couldn't I, write it as 60 minus 45? 60 minus 45 is also 15. So there isn't only one way to do this. They'll both give me the same correct answer. So the idea here is if I write cosine 15 degrees as the cosine of 45 degrees minus 30 degrees. Because 45 minus 30 is 15. So you can see I'm writing it as 2 angles, one minus the other. And the reason I'm choosing those two is because both of these are included in the table at the top of the page. So you can see if I look at the cosine A minus B formula, so the cosine A minus B formula is this one here. Okay, you can see it's the one in the very top right-hand corner. That one there. So that's the formula that I'm going to be working with in this particular question. So I'm not going to write the formula down every time, but you can see the cosine A minus B formula looks like that. So cosine A minus B is written this way. It's cosine A, cosine B, plus sine A, sine B. And that's my formula from the top right-hand corner of page 14. So you can see in this formula here, A is 45 degrees and B is 30 degrees. So I can just fill that in then. So if A is 45 degrees, cosine A is cosine 45 degrees. So it's cosine 45 degrees like that. Cosine B, and B is 30 degrees, that's cosine 30. Right? Plus sine A, sine B is sine 45, sine 30. So I'm using that formula there, that essentially it's this formula here I'm using. In my version here, A is 45 degrees and B is 30 degrees. So I'm just replacing A and B on the right-hand side with 45 and 30. And you'll notice all of these 4 here, cosine 45, cosine 30, sine 45, sine 30, they can all be found from the table at the top of the page. That's the idea here. So I just fill in the values. So cosine 45 degrees, you can see from the table, is 1 over root 2. Okay, that's in the table. cosine 30 degrees from the table at the top of the page is root 3 over 2, right? Plus sine 45 degrees is 1 over root 2. And sine 30 degrees is a half. Right? Now, technically speaking, I could now, if I want to, put that into my calculator. Even though it says don't use your calculator, really what that means is I don't want you to just type that into your calculator and press equals. Now, once I've shown a bit of manipulation here, I could, if I want to, put this into my calculator. I'm not going to use the calculator at all, but it wouldn't be wrong now to put this into your calculator and get the answer, because you've shown the examiner what it is he's looking for here, that you know how to use that formula. You're able to break the 15 into two angles like this, right, as a compound angle that way, and where both of these angles here are ones whose sine, cosine, and tan you can find from the table provided at the top of the page. Okay, so if I was to tidy this up here, when you multiply two fractions together, multiply the tops and multiply the bottoms, so 1 by root 3 is root 3, okay, and root 2 by 2 is 2 root 2. Okay, plus, again, 1 by 1 is 1, and root 2 by 2 is 2 root 2. So you'll notice that because those two fractions have the same denominator, I can add them together, so I get root 3 plus 1 over 2 root 2. They've got the same denominator. Now, it's not great practice to leave a surd below the line like that. It's not wrong. That one's okay. But what I'm just going to do here is I'm just going to remove the surd from below the line here, just to make the answer a little bit tidier. All right, see if it'll simplify. Now, you can't square the top and bottom. So if you want to remove that surd from the bottom, you can't square the top and bottom, because remember, if you're dealing with a fraction, say for example, if you have that fraction there, 3 over 4. If I square the top and square the bottom, it means I'm squaring this and I'm squaring that. So I'm multiplying that by 3 and I'm multiplying that by 4. Okay, because when you square the 3, you're multiplying 3 by itself. When you square the 4, you're multiplying 4 by itself. So I'm multiplying top and bottom of the fraction by different numbers, and therefore the fraction changes. So if you square the top and bottom of a fraction, it doesn't remain intact. Okay, what I'm going to do instead is I'm going to multiply everything top and bottom by the surd below the line. So I'm going to multiply below the line by root 2. I'm going to multiply this by root 2. And I'm going to multiply both of the terms above the line by root 2. So multiply everything above and everything below by root 2. Okay, so you can see here, root 2 by root 3 is root 6. Remember, you've got that rule there, that square root of a times the square root of b is just the square root of ab. So if you multiply two square roots together, you can just multiply the numbers under the square roots together. Okay, so root 2 by root 3 is root 6. 1 by root 2 is root 2. And below the line, root 2 by root 2 is 2. And 2 by 2 is 4. And that's my answer. And in fact, if you put this into your calculator, that's the answer it'll give you. It'll tell you it's root 6 plus root 2 over 4, right? So here's part 2, sine 105 degrees. So the trick is, can I write 105 degrees as two of the angles from the table at the top of the page added together or subtracted? Well, I don't think I can subtract two of those angles to get 105. Could I add two of them? Well, yeah. I can add 60 and 45. So I might write this here as sine 60 degrees plus 45 degrees. Okay? And you can see then, in this case here, I'm going to use the sine A plus B formula, because that's what I've got here. I've got the sine of two angles added together. And sine A plus B, you can see, is sine A cosine B plus cosine A sine B. All right, so that's the formula from page 14 I'm going to use here, because essentially I've got the sine of two angles added together. So you can see in this case here, A in the formula is going to be 60 degrees, and B in the formula is going to be 45 degrees. So I'll just sub those values in. So that means that the sine of 105 degrees is sine, so I'll replace A here and here with 60. So I get sine 60 degrees like that. And I'll replace B here and here with 45 degrees. So it's going to be cosine 45 degrees plus cosine A is cosine 60 and sine B is sine 45 degrees. So just replacing the A and B in this formula here with 60 and 45. Okay, and again, so all four of these now I can grab from the table. So sine 60 is root 3 over 2. Cosine 45 is 1 over root 2. Cosine 60 degrees is a half. and sine 45 degrees is 1 over root 2. And you'll notice if you add those together, it's exactly the same as the previous question. You get root 3 over 2 root 2 plus 1 over 2 root 2. So if I add those two together and then tidy up the fraction like we did in the previous question, I get the very same answer. It's root 6 plus root 2 over 4. So once you get this far, you'll notice it's exactly the same as the previous question. No difference at all. Okay, that's my answer. And again, that's the answer you get. So obviously you can pop that into your calculator at the end and just check I do get the right answer, make sure I've done it correctly. Part 3 then on the next page, page 286, we're asked to find the tan of 15 degrees. So again, there's a couple of ways I could make up the 15, couldn't I? I can't add two angles together to get 15, but I can subtract two of them. 45 minus 30 is 15, and 60 minus 45 is 15. Either of those will work fine. They'll both give me the same correct answer. Okay, there's no problem with that at all. So what I'll just do, I'm going to go with 45 and 30. So I'm going to write that as the tan of 45 degrees minus 30 degrees. Because 45 minus 30 is 15. And then the tan form we're going to use, tan of A minus B is tan A minus tan B over 1 plus tan A tan B. Now I don't need to write the formula down every time, but that's the formula I'm going to use. You can see that one is on page 14 up in the top right hand corner. Okay, so that's the one I'm going to use here. So in this particular calculation here, I'm going to replace the A in the formula with 45 degrees, and I'm going to replace the B in the formula with 30 degrees, and I'm going to get my answer. So tan of 15 degrees then, it's going to be tan A, which is 45 degrees, okay, minus tan B, minus tan 30 degrees, over 1 plus tan A tan B, 1 plus tan 45 degrees, times tan 30 degrees. And I can just pull those out of my calculator and then simplify from there. Okay, so tan of 45 degrees, you'll notice, is 1. Tan of 30 degrees from the table is 1 over root 3. So it's 1 minus 1 over root 3. Over 1 plus tan 45 degrees is 1 times 1 over root 3, like that. Okay, so I get 1 minus 1 over root 3 and 1 plus 1 over root 3. Now again, leaving the surds like that is not great practice. So I will tidy this up as far as I can. Okay, that answer is correct. It's just not maybe as simple as I can make it. And because of the fractions here and here, anytime I've got fractions inside fractions, to deal with that, I'll treat the top and bottom of a fraction the same way I treat the right and left-hand side of an equation. As long as I multiply them by the same thing, nothing changes. All right, so if I multiply the top and bottom of a fraction by the same thing, nothing changes. So I'm going to multiply everything top and bottom by this denominator here. I'll multiply this by root 3. 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 Everything top and bottom by root 3 should do the trick here. So root 3 by 1 is root 3. And then the root 3's will cancel here. I just get left with minus 1. And there root 3 by 1 is root 3. And then again, the root 3's will cancel, I get plus 1. So that's a bit better. There's no fractions left. But like the previous couple of questions, I'm not a fan of leaving a surd below the line like that. That answer's right. But that's not the way it'll appear if you pop it into your calculator. Your calculator will not give it to you with a surd below the line. So the thing here is, because it's not just a surd on its own here, it's a compound surd because we've got a number added as well here. To get rid of the surd below the line this time, I don't just multiply top and bottom by root 3. Because I multiply that by root 3, I'll get 3. But when I multiply that by root 3, I'm going to reintroduce root 3. So what I do remember here is a little bit like you meet in complex numbers. I multiply the top and bottom by the conjugate of the bottom. So just change the sign of the middle of the one on below the line here. Okay, so that'll be root 3 minus 1. And do the same above the line. Okay, so multiply top and bottom by the conjugate of the bottom. Because remember, the idea here is that because these two signs are different, this will be the difference of two squares, which will remove the square root sign. Okay? So if you just notice, look what that looks like here. So root 3 by root 3 is 3. Root 3 by minus 1 is minus root 3. Minus 1 by root 3 is minus root 3. And then minus 1 by minus 1 is plus 1, like that. And then below the line, root 3 by root 3 is 3. Root 3 by minus 1 is minus root 3. Plus 1 by root 3 is plus root 3. That's the point. Because you can see those two, the plus and minus root 3 will cancel there. And plus 1 by minus 1 is minus 1 like that. Okay? So just notice then what I'm left with when I do that. So above the line, 3 plus 1 is 4. Okay? And then minus root 3 minus another root 3 is minus 2 root 3. Right? And that's all over 3 minus 1, which is 2. And notice the way both terms above the line will divide by 2. 2 into 4 goes twice. And the 2's will get there, so I get 2 minus root 3. And that's my answer. That's much tidier. And that's the way it'll appear from your calculator. So just remember, if you're doing a question of this type, that the important thing is to be able to get to this guy here. So I can break that number into two smaller angles, added or subtracted, pull out the corresponding formula from page 14 or 15 and drop the angles in, and then get the values for these individual tans here from the table I was given on page 13, right? So kind of everything beyond this point is algebra. It's not quite as important in terms of testing your trigonometry as getting this far here. But try, if at all possible, not to leave an answer with a surd below the line. It's not wrong if you do, it's just not as simplified as it could be, and it won't match what you get from your calculator if you want to use your calculator to check. So if you've just got a square root number by itself below and multiply top and bottom by that square root, that'll remove it. If you've got a compound surd like this where there's a square root and a number, multiply top and bottom by the conjugate. Change the sign in the middle there so you get the difference of two squares going on, and then multiply top and bottom by that. That will remove the fraction you're dealing with. So it might just be worth pausing the video there and just checking the next couple to make sure you can do them before we kind of move on to the next sort of question. Okay, so here's the next one, cosine 75 degrees. Again, the only way I can make up 75 degrees is 30 and 45. So I'll write that as cosine 30 degrees plus 45 degrees, order doesn't matter. Okay, like that. And then I'll use the cosine A plus B formula from page 14. And if I do, that's going to be cosine A cosine B. That's cosine 30 degrees times cosine 45 degrees. Minus sine A sine B is minus sine 30 degrees sine 45 degrees. So that's the cosine A plus B formula from page 14 of your formula booklet. Cosine A, cosine B, minus sine A, sine B. I'm just replacing A in the formula with 30 degrees and B with 45 degrees. And then if I grab these from my formula booklet, or from the table, so cosine 30 is root 3 over 2. Okay, cosine 45 degrees is 1 over root 2. Then sine 30 degrees is a half. And sine 45 is 1 over root 2. And if you tidy those up there, you can see it's root 3 over 2 root 2. There, when I multiply those two together, minus 1 over 2 root 2. And if you tie that up the same way we did in parts 1 and 2 of this question, kind of won't go through that again, you get root 6 minus root 2 over 4. And that's the best answer to give there, no surd below the line. Okay? The next one then, sine 120. There's a few ways I could make up that one, isn't there? I could say sine 120 is 90 plus 30. I could also, couldn't I say it's 60 plus 60? Again, there's more than one way of doing this. It's entirely up to you. So if I go with, say, sine of 60 degrees plus 60, I said 90 plus 30 will work perfectly well as well. So you can see I'm now going to use the sine A plus B formula. You could also have said 180 minus 60 is 120. So there's three different ways you could do this one. All right, it's entirely up to you. They'll all give you the same correct answer. So the sine A plus B formula is sine A cosine B plus cosine A sine B. Okay, so I'm going to replace the A with 60 and the B with 60. All right, so what I'll end up with there is it's sine 60 degrees, cosine 60 degrees, right? Plus cosine 60 degrees, sine 60 degrees. That's just filling 60 degrees in for A and B in the sine A plus B formula, because I'm writing this number, the 120 is two things added together. So again, if I grab these from my formula booklet, so you can see actually they're both the same. So if you want to tie that up, you could just write that, couldn't you, as 2 times sine 60 times cosine 60. Because these two are identical. So I can just write it like that. That's going to be 2 times sine of 60 degrees is root 3 over 2. And cosine of 60 degrees is a half. And give me say 2 times half will cancel. Your answer there is just root 3 over 2. Okay, so the answer for that one there is root 3 over 2. Okay, so here's the next one then. Cosine 210, it's part 6 on the next page. So cosine 210, how do I make up 210? Well, I think the only way I can make up 210 with the angles given in the table at the top of page 285 is 180 plus 30. So I'll write it that way as cosine 180 degrees plus 30 degrees, and then I'll use the cosine A plus B formula. Okay, replacing A with 180 and B with 30. And that formula, cosine A plus B, it's cosine A, cosine B, minus sine A, sine B. Okay, so cosine A, cosine B, minus sine A, sine B. So it's cosine 180 times cosine 30 minus sine 180 times sine 30. Okay, and then I'll just pull those values out of the table. So cosine 180 is minus 1. Cosine 30 is root 3 over 2. Sine 180 is 0, okay, which is kind of nice. And then sine 30 degrees is a half. Okay, so this will disappear here. So I just get minus root 3 over 2 is my answer there. And then second last one, tan 105. Again, how am I going to make up 105? I think probably 105 is 60 plus 45. It's probably the best way to go about finding that one. I can't think of any other way of looking at that one. What I could actually do, if you think about that, so if I didn't want to do it, I'm going to do it this way. I'm going to say it's tan of 60 plus 45 degrees. Okay? Right? You do have an alternative though, if you think about it for a second. If you look back up at part 3 of the question. See, in part 3 of the question, you know what tan 15 is. So couldn't I write that as 90 plus 15? So while I can find the tan of 90 from my tables, okay, but to find I'd also need the tan of 15, which is not given the tables, but I do know it from part 3 of the question. So it wouldn't be wrong to write that as 90 plus 15. The tan of 90 I can find from my formula booklet, okay, the table given in the question, and the tan 15 degrees I have from part 3 of the question. So I could use answers from earlier on if I thought it was going to make it easier. So in this case here, it's the tan A plus B formula I'm using, which is tan A plus tan B over 1 minus tan A tan B. So again, that's going to be A there, that's going to be B. So my answer is going to be tan A plus tan B. So it's tan 60 plus tan 45 over 1 minus tan A tan B. It's 1 minus tan of 60 times tan of 45 degrees. So it's the tan A plus B formula I'm grabbing from page 14 and then dropping 60 in for A and 45 in for B. Okay, then if I pull these guys off the table then, so tan 60 degrees is root 3, tan 45 is 1, and then that's 1 minus tan 60 is root 3 times 1. So you can see that's root 3 plus 1 over 1 minus root 3. And just like we did back in the question, in part 3 of the question, if I multiply top and bottom by the conjugate, this say 1 plus root 3 or minus 1 minus root 3, whichever you want. You can change either sign. It doesn't really make any difference in the case of a surd like that. So if I do the multiplication top and bottom there, in that one I get minus 2 minus root 3. So that's just multiplying top and bottom by the conjugate of this guy here, like we did back in part 3 of the question. Okay? And then our last one then, tan 75, this one here. Again, to find tan 75, I could, because I've got tan 105 from the previous question, okay, I could maybe use tan 105, it's 105 minus 30. I could do it that way, but I'm just going to stick with using angles from the table. So I'm going to write that as tan of 30 degrees plus 45 degrees. Okay, so it'll be the same tan A plus B formula we had a moment ago, replacing A with 30 and B with 45. So it's going to be tan 30 degrees. So it's tan A plus tan B. So it's tan 30 degrees plus tan 45 degrees over 1 minus tan A times tan B. Okay, and again, if I just pull those values off the table, it's 1 over root 3 plus 1 over 1 minus 1 over root 3 times 1. And that gives me 1 over root 3 plus 1 over 1 minus 1 over root 3. And that's very like the fraction we had back in part 3, where we're doing tan 15. So I think to get rid of the fractions inside the fraction, I'll multiply top and bottom by root 3 first of all. Okay, just to remove the fractions there. If I multiply everything top and bottom by root 3, multiply that by root 3, and that by root 3, and then that by root 3. So everything top and bottom by the denominators, right? Because you can see here, they'll cancel and just leave me with a 1. And then, so I get 1 plus root 3 like that, because 1 by root 3 is root 3. Root 3 by 1 is root 3. And then they'll cancel, minus 1 like that. And then again, if I multiply top and bottom by the conjugate of this guy here, root 3 plus 1, I'll get a nice round answer. And that's 2 plus root 3. And that's the way to come out of your calculator. So it's, as I said, the two things to watch out for there is, first of all, to make sure I know how to form this angle here by creating either the sum or difference of two of the angles given in the table at the top of the page. Or the sum or difference of angles that maybe I've calculated tan, sine, or cosine of in a previous part of the question. And then pull out the relevant identity or formula from the top of page 14 and drop the values in, right? That's kind of the trigonometry bit done once I get as far as here. I drop the values in. Then when you're dealing with surds like this, if you want to check using your calculator will not give you an answer with a surd below the line. So to deal with that, the trick is, if you've got a fraction like that, where say it's root 3 plus 1 over root 2, just multiplying top and bottom by that square root there will get rid of it. Okay, because root 2 by root 2 will give you 2, a number below the line. When you've got a compound surd like this, where you've got a square root and a number, multiply top and bottom by the conjugate of this guy here by changing that sign, the sign in the middle there. Okay, that'll make a number out of this, a real number out of this, okay, a whole number out of this I should say, and then you can do the simplification if necessary. Okay? So, question 2 then on the next page, page 288, the first part looks like this. Okay, so the question, it says you're given that alpha and beta are acute angles. Okay, so alpha and beta are acute angles such that the tan of alpha is a quarter. So tan of alpha is a quarter and the tan of beta is 3/5. Without evaluating alpha or beta, find alpha plus beta. So obviously if I was allowed to find them, I could just say, well look, alpha is going to be the inverse tan of a quarter. So I could just go ahead and use my calculator to find how big the angle alpha is. Remove the tan from both sides by using inverse tan. So the inverse tan of a quarter, and that beta is the inverse tan of 3/5. So I could find how big alpha and beta are, and then just add them together to find the answer. But he says, no, I don't want you to do that. Don't find alpha or beta. Just work out what alpha and beta is without doing that, right? So again, you notice alpha plus beta here. I have a formula that tells me what tan A plus B is. Okay? So tan A plus B, remember that's on the top of page 14. It's this one here, right? And if you look at then what I can do with that, if I replace A with alpha and B with beta, I'll have an alpha there, a beta there, alpha and beta, and you can see I'll be able to fill in the angle, the values I've got here. That would mean that the tan of alpha plus beta is equal to tan alpha, which is a quarter, right, plus tan beta, which is 3/5, over 1 minus tan alpha is a quarter times tan beta is 3/5, like that. Okay? And if I just pop that into my calculator exactly as it appears there, that gives me 1. So if I put this into my calculator, I get the number 1. So tan alpha plus beta is equal to 1. That means alpha plus beta then is the inverse tan of 1. So I can find the inverse tan of that because I'm not finding alpha and beta. The inverse tan of 1. And again, because he said that, look, alpha is between 0 and pi over 2, remember that means that we're looking for the answer in radian mode. So make sure your calculator's in radian mode. And you get the inverse tan of is 45 degrees. It's pi over 4. So alpha plus beta is pi over 4. That's the size of the two angles in that case. Right? So then, question 3 on the same page. This is going to bring us back to something that we mentioned in an earlier lesson. It says you're given that x and y are acute angles, and sine x is 12 over 13, and cosine y is 4 over 5. It says without evaluating x or y, find sine x plus y and tan x minus y. Now, if I want to find sine x plus y, right? Which is what I'm looking for. So I'm trying to find out what sine x plus y is. Okay, that's two angles added together. So remember, if I use my formula, my compound angle formula for sine A plus B, right? That's the one that's at the top of page 14. And sine A plus B is sine A cosine B plus cosine A sine B. So all of these compound angle formulas I'm using here, they're all on page 14, top of page 14 of your formula booklet. So if I apply that here, I'll just replace A with X and B with Y. I'm trying to find sine X plus Y. So these are both going to be X, they're both going to be Y's. So I'll get sine X cosine Y plus cosine X sine Y. Now notice, in this case, sine X I have. Okay? Cosine Y, I have. I don't know what cosine X is. That's not given. I don't know what sine Y is. Right? So if you remember back in lesson number 1, the very first lesson we dealt with, where you're working with Pythagoras' theorem, I showed you a couple little questions along the same lines as this. That if I know one of the ratios for a right angle triangle, I can very easily find the other two using Pythagoras' theorem. So if you remember that sine is opposite over hypotenuse, okay? So that's opposite there over hypotenuse. So we're dealing with a right angle triangle there where the side opposite the angle x is 12 and the hypotenuse is 13. So what does that triangle look like? Okay, well there's the angle x there. The opposite is 12 and the hypotenuse is 13. So when he gives me sine, tan, or cosine, he's giving me two sides of a right angle triangle. I can use Pythagoras to find the third one. So if I use Pythagoras here to find the third side, which is the adjacent, all right? Now remember what that means is 13 squared is equal to 12 squared plus the adjacent squared. Okay, so we move this across. So 13 squared minus 12 squared is equal to the adjacent squared. And that means the square root of 13 squared minus 12 squared is equal to the adjacent, and the adjacent comes out there as 5. Okay, so this side here is 5. And now that I know that the remaining side here is 5, can't I now write down what cosine x is? Because cosine x is adjacent over hypotenuse, 5 over 13. So back in lesson 1, when I was showing you that kind of trick there, if the examiner gives you sine or cosine or tan like this, he's giving you two sides of a right angle triangle. You can find the third side using Pythagoras, and that will let you write down either of the other two ratios. So if he gives me sine, I can write down cosine or tan. If he gives me cosine, I can write down sine or tan, and so on. Right? That's the same, but that's what I'm using here. Okay, so I now know what. So I know sine x is 12 over 13. Right, that was given the question. And cosine y is 4 over 5. Right? I now know that cosine x is adjacent over hypotenuse 5 over 13. Like that. And to find sine y, I'll do the same with this triangle here. So again, cosine, remember, is adjacent over hypotenuse. So that right angle triangle looks like this. Okay, right angles there. All right, there's y. And the adjacent here, that's 4. And the hypotenuse here is 5. The side I don't know in that triangle is the opposite. So we do the very same calculation there. So 5 squared is equal to 4 squared plus the opposite squared, just applying Pythagoras' theorem. We'll move this across by subtracting 4 squared from both sides. Okay, like that. And then take the square root. 5 squared minus 4 squared is equal to the opposite. And the opposite there turns out to be 3. So now that I know the third side, I can now write down what sine y is. So sine y is opposite of hypotenuse, 3 over 5. And if I pop all of that into my calculator there, I can find the angle I'm looking for. So that turns out to be 63 over 65. Okay, if I do the addition there. And then to find tan a, to find the other bit then, tan a, or x minus. So tan x minus y, then the other thing I was asked to find there. Again, if I use my formula, it's going to be tan x minus tan y. I'm just going to use the tan a minus b formula. It's tan x minus tan y over 1 plus tan x tan y. Right? So just notice then what tan x is. So in this triangle here, tan of x, remember, is opposite over adjacent. It's 12 over 5, okay? And tan y is opposite over adjacent. It's 3 over 4. So I can use the triangles I just worked with there to find tan x and tan y. Okay, so tan x is 12 over 5. Minus tan y is minus 3 over 4. Over 1 plus tan x, which is 12 over 5, times 3 over 4. And again, if I just pop that into my calculator, I get 33 over 56. Tricky little question, that one. But again, harking back to something that we mentioned back in lesson number 1. So if we move then to page 289, so 289 then we start working with the double angle formulas, right? And obviously a double angle is an angle that's multiplied by 2. Okay, so sine 2a, cosine 2a, tan 2a. And again, you can see there are 7 formulas that we would be working with when we're dealing with double angles. And again, they're all in your formula booklet. So these ones are in the bottom half of page 14. So if I look at page 14 of my formula booklet again, you can see here they are in the bottom half. So there they are, cosine 2a, sine 2a, tan 2a, cosine 2a, sine 2a. So there's formulas for the double angle like that. And you can see they're also kind of found in these 2 formulas here, okay, which are kind of rearranged versions of the ones above, all right, for cosine squared a and sine squared a. So we've got a number of angles there for dealing with double angles, all on the bottom half of page 14 of your formula booklet, okay? The other thing then to draw your attention to on the next page, on page 290, are formulas for converting products into sums and differences and back again. Now these identities are particularly useful when I'm doing integration. Okay, where because I don't have, when you start dealing with integration, we'll be looking at that on the Leaving Cert course, we don't actually have access to a technique for integrating a product of trigonometric functions, 2 things multiplied together. So essentially what I've got to do is try and turn it into a sum or difference, because that I can integrate. So we're not going to get ahead of ourselves here. But the key thing is there are formulas for converting the product of 2 trig functions into a sum or a difference. 2 trig functions added together or subtracted. And again, you can see they're mentioned for you there on page 290, and they're also in your formula booklet on page 15, kind of the only page we haven't looked at yet. So on page 15, there, here they are here. So page 15, sorry. So page 15. Right, here it is here. There we go. So page 15, you can see here, so there's a product. It's 2 trig functions multiplied together, and you can see it's turned into a sum. 2 functions added together, okay? And there again, product into a sum, a product into a difference, a product into a difference. And then here's going the other way around. There's a sum turned into a product. There's a difference turned into a product. So these formulas here are for switching between 2 trig functions added or subtracted into 2 of them multiplied together, or vice versa. And these are kind of more important when we get to integration, but you kind of see that when we eventually make our way there. So if you look at the question then, on the first question there on page 291, just a couple of short questions here to finish up this lesson. Where it says to find k and events such that sine 105 degrees, okay, minus sine 15 degrees is equal to 1 over root k. So we're asked to find the natural number k for which that's true. Okay, so if you look at your formulas, what we've got on the left-hand side here is we've got one sine minus another. All right, so if you look at your formula booklet then again on page 15. So it's one sine minus another, and you can see down here, there's a formula, one sine minus another. So in this case here, I'm going to replace a and b in this formula with the 105 and 15 degrees we have in our question here. All right, so again, like the previous questions, it's just a matter of grabbing an appropriate formula from page 14, 15 and using it. So in this case here, the one that we're using is sine a minus sine b, because we've got one sine minus another. So sine a minus sine b, it's written as 2 times cosine a plus b over 2 times sine a minus b over 2. So you can see in this formula here, I'm going to replace A with 105, and I'm going to replace B with 15. Okay? So what we're going to get here is 2 times cosine A plus B is 105 plus 15, that's 120 over 2. So A plus B is 105 plus 15, that's 120 over 2, times sine A minus B is 105 minus 15, that's 90. So it's 90 over 2, okay? And that's going to be 2 times cosine 60 degrees times sine 45 degrees, because 120 divided by 2 is 60, and sine 90 divided by 2 is 45. And again, I can now go to my tables on page 13 to find the corresponding values. So 2 times cosine 60 is a half, and then sine 45 degrees is 1 over root 2. Okay, that's according to page 13 of my formula booklet. Okay, same table we were kind of dealing with previously. And you can see 2 times a half is just 1. So I get 1 times 1 over root 2, which is 1 over root 2. So you can see, look, I'm told that the answer should be 1 over root k. It's actually 1 over root 2. So that means that k is equal to 2. Okay, so the k I'm looking for my answer is the number 2, like that. Okay. Okay, then in question 5 on the same page, we're asked to simplify this. Cosine x minus 30 degrees minus cosine x plus 30 degrees, okay? So again, there's kind of more, as usual, there's more than one way of doing this. If I go to page 15, there's a cosine A minus cosine B formula. And my cosine A minus cosine B formula looks like this. So it's cosine A minus cosine B is equal to minus 2 times sine A plus B over 2 times sine A minus B over 2. So again, that formula there, because what I've got, I'm trying to simplify here, is one cosine minus another. So it's the cosine A minus cosine B formula I'm using. And again, I'll just replace A in the formula with x minus 30. Okay, and I'll replace the B in the formula with x plus 30 degrees. Okay, so we're going to get there then. If I want to tidy that up, it's going to be minus 2 times sine A plus B over 2. Now notice what A plus B is. It's that plus that. So it's x minus 30 plus x plus 30 over 2. That's what A plus B over 2 is. It's this plus this over 2. And you can see the 30 degrees will cancel there, and you just get 2x over 2. That's x. So I'm just going to get sine x like that. So A plus B over 2, it's these two added together and divided by 2. So if I add the two of them together, it's x minus 30 plus x plus 30. The minus 30 and plus 30 degrees will cancel, giving you 2x. So you end up with 2x over 2, which simplifies to just x, right? So what about this one then? A minus B over 2. Well, A minus B is x minus 30 degrees minus x plus 30 like that. Okay, so you can see that way. So, and that's all over 2. So you're going to get x minus 30 degrees minus x minus 30 degrees like that as well. And that's all over 2. And this time the x's cancel, and I get minus 60 over 2, which is minus 30. So I get sine of minus 30 degrees like that. Okay, so that's how I simplify that. So now I can work out what sine of minus 30 degrees is using my calculator, using my tables. Okay, so I get minus 2 times sine x, and the sine of minus 30 is minus a half. Your calculator will tell you that. And then minus 2 by minus half, that's just plus 1, because minus by minus is plus, and 2 by half is 1, so I get 1 times sine x. So that just simplifies to sine x. Is the answer for that one there. Okay? Okay, so our second asked question is the one on page 292. So we're told that A and B are acute angles, so they're both acute, they're both between 0 and 90, such that the tan of B is a quarter, and the tan of A minus B is 2, right? So we're asked to, without evaluating A or B, find tan A and find sine 2A. So first of all, finding tan A, we're going to use a formula that we've met already, because notice I know what tan A minus B is. So I've got my formula from page 14 that tells me tan A minus B is essentially tan A minus tan B over 1 plus tan A tan B. So again, that formula is on page 14, top of page 14. Now I don't need to memorize these formulas. When I'm working with something like this, I'll just open up page 14, 15 and have a root around and see if I can find some that'll get me out of jail here. So I've got that formula there because you'll notice I know what this guy is. So I know that's going to be the number 2. And I know what this guy is. Okay, that's going to be a quarter. The only thing I don't know is tan A, which is what I'm trying to find. Okay, so let me just maybe say for a moment, just rather than keep writing it out that way, let me just say the tan A, let's just call that x for a second. And if I fill the formula in then, tan A minus B is 2, right? Tan A is x minus a quarter like that. So 1 plus x times a quarter that way. Okay, and you can see if you just tidy up that fraction there, it's x minus a quarter and 1 plus x over 4. If I multiply x by a quarter here, I get x over 4. So obviously what I got to do is I got to get rid of the fractions inside the fractions here, and I'm going to have to multiply both sides by the denominator here to get rid of the fraction on the right-hand side. And I can do those in either order. It doesn't really matter what order we do them in here. I'm going to get rid of the fractions within the fractions first. So we met this earlier on this lesson. If I've got fractions inside fractions, I'll multiply top and bottom by a common denominator. That should remove the fractions. So the common denominator here is 4. So I'll multiply that by 4, and that by 4. I'll multiply that by 4, and that by 4 as well. And if I do that here, I get 4x there. They'll cancel at minus 1. And 4 by 1 is 4. And then they'll cancel plus x like that. So that's all equal to 2. Right, so I've got this fraction here now equals 2. And again then, to tidy that up, I'll multiply both sides by the denominator. Remember, that's how I deal with an equation that contains fractions. I'll multiply both sides here by 4 plus x. Because if I do that, they're going to cancel on the right-hand side. So what I've got on the left-hand side here, 2 times 4 is 8. Okay, and 2 times x is 2x, like that, is equal to, they're gone, it's 4x minus 1. And there we go, it's easy enough to solve for x there. Bring the 2 across, the 2x across, I get 2x over here, it is equal to 9. So 9 over 2 is equal to x. Okay, so that's what tan A is. Okay, so tan of A is 9 over 2, is my answer there. Okay, so that's just using a formula as we've just done already. Okay, so the tan of A is 9 over 2. That's the first part. Now, to find sine 2A, I'll go to my formula book at the bottom of page 14 and find a formula for sine 2A. And there is a formula there that tells you what sine 2A is equal to. That on page 14, I know that sine 2A is equal to, there's a couple of formulas I can use to do this one. So if you look at page 15 of your formula book, sorry, page 14 of your formula booklet there for a second, right? So you can see here that what I could do is I can use this formula here. Because in order to find sine 2A, all I need to know is what tan A is. All right? You notice there's another one up here, sine 2A. There's a second one up here. But to do that, I need to know what sine of A is and what cosine of A is. Right? So I could use that one there as well. But remember, as we've kind of met previously, if I know that tan A is 9 over 2, isn't tan opposite over adjacent? So I could say, look, that means that the opposite is 9 and the adjacent is 2. And I could set up the right angle triangle there, use Pythagoras theorem to find the hypotenuse. And once I know what the hypotenuse is, I could then write down what sine and cosine are, and I could use that formula. So again, I've always got options here, but it makes sense to me because we know what tan A is already. Let's just use the tan formula. Okay, so sine 2A is equal to 2 tan A, okay, over 1 plus tan squared A. Like that. Okay, so 2 tan A is 2 times 9 over 2 times 1 plus 9 over 2 squared. And that will give me my answer there. And that comes out at, 36 over 85. If I put that into my calculator, I get 36 over 85. Very same answer I would have got if I did it the other way. If I used the right angle triangle idea here to find the hypotenuse and then used 2 sine A, sine 2A is 2 sine A cosine A, I would have got the very same answer. Okay? So our final question then, the one on page 293. You're given this, you're given that sine of x plus pi over 6 plus sine of x minus pi over 6 is equal to 4/5 root 3. And you're told that x is between 0 and pi over 2. Okay, so in other words, that x is between 0 and pi over 2. Like that, which means x is an acute angle. Okay, between 0 and pi over 2. So we're asked to find what sine x and tan x are. So first of all, notice what I've got here. I've got one sine plus another. So I've got the sum of 2 sines here. So one sine plus another. So I'll go to the bottom of page 15 and I'll find a formula for what that looks like. Okay, so the formula I'm going to have a look at, the formula I'm going to use here is this one. So yeah, so I've got one sine plus another. So I'm going to use this one here. Sine A plus sine B. So I'm going to replace the A in this formula with x plus pi over 6 and the b with x minus pi over 6. Right, so I'll use this one here. So sine A plus sine B, because that's what I've got there. I've got 2 sines added together, is the same as 2 times sine A plus B over 2 times cosine A minus B over 2. Right? So you can see in this formula here, A is x plus pi over 6, and B is x minus pi over 6. So I can tidy up the right-hand side there now, or sorry, the left-hand side. I've got 2 times. So first of all, it's sine A plus B over 2. So if I add those together, it's x plus pi over 6 plus x minus pi over 6 over 2. That's A plus B over 2. That's this guy here. And you can see the pi over 6 is cancelled. So I get 2x over 2. That's just x. So that's going to give me 2 times sine x. Right? Now, cosine A minus B over 2. So what's A minus B? Well, it's x plus pi over 6. Take away x minus pi over 6. Right? And that's all over 2. So you can see plus x and minus x. They're going to cancel. And minus by minus gives you plus here. Okay, so that's going to be 2 times pi over 6 all over 2. The 2's will cancel. That's just going to give me pi over 6. Okay, that's going to be cosine pi over 6 is equal to 4/5 root 3. And now I should be able to solve for sine x, because you can see here that cosine pi over 6, if I work out what cosine pi over 6 is, cosine pi over 6 is, sorry, where am I? So cosine pi over 6 is root 3 over 2. Sorry about that, all right? This guy here is root 3 over 2. So it's 2 times sine x times root 3 over 2 is equal to 4 over 5 times root 3. These guys will cancel here, and you can see I've got a root 3 on both sides here. I can cancel the root 3's, so I get that sine of x is 4 over 5. Right, that's sine x. And then to find tan x, well, there's that same trick we've talked about a couple of times already in this lesson, and we met back in lesson 1. If I know what sine x is, that means I know 2 sides of a right angle triangle. Sine of x equals opposite over hypotenuse. Right? So the right angle triangle looks like this. Okay, so there's x there. The opposite here is 4. The hypotenuse is 5. The side we don't know there is the adjacent. So I can find the adjacent using Pythagoras theorem. So 5 squared equals 4 squared plus the adjacent squared. So 5 squared minus 4 squared is equal to the adjacent squared. So the square root of 5 squared minus 4 squared is equal to the adjacent. And that's equal to 3. So this side here is 3. And then remember, so if we're asked to find what tan x is, tan of x is opposite over adjacent, which is 4 over 3. So tan of x is 4 over 3. right? So the final piece then, if tan x plus y is equal to a half, we're asked to find tan y as a fraction. Okay, so again, we've met this kind of tan a plus b formula a couple of times. Okay, so remember your tan a plus b formula, top of page 14, it's tan a plus tan b over 1 plus tan a tan b. Right, so if I apply that formula here, you can see I'll replace a with x and b with y. I get that tan x plus y is tan x plus tan y over 1 minus, sorry, that's a minus sign there, that one, 1 minus tan x tan y. And in that formula there, I know what tan x is from the first part of the question. I know what this is because it's given. I just have to solve for finding tan y. So let me just call tan y a for a second. Just pick a different letter rather than writing out tan y every time. I don't need to do that. So tan x plus y, that's a half, is equal to tan x, which is 4/3 from the previous part of the question, plus a over 1 minus 4/3 times a. And I just have to solve for a there. That's the value I'm looking for. Okay? So again, tidying up that fraction there, it's 4/3 plus a over 1 minus 4a over 3. When I multiply these together, I get 4a over 3. And like the question we did a couple of moments ago, okay, I've got fractions within fractions there, and I've also got an equation to solve. So I need to remove the fractions within the fraction here. I need to get rid of the fraction of the equation overall. I can do those two steps in any order I like. So like I did previously, I'm going to remove the fractions inside the fractions first, multiply top and bottom by a common denominator. So I multiply this by 3, this by 3, this by 3, and this by everything top and bottom by a common denominator. And when I do that, the 3's will cancel there. I get 4, all right? And a by 3 is 3a, so I get 4 plus 3a there. Then 3 by 1 is 3. 3's will cancel out 3 minus 4a, and that's equal to the half we were given in the question as our value for tan x plus y. And now I just have to solve that equation there to find the value for a, right? So that's going to multiply both sides by your denominator here. Remember, that's how we get rid of fractions. Multiply both sides, or multiply top and bottom, by a common denominator. Because they're going to cancel on the right-hand side. And I just get 4 plus 3a here. And then on this side here, you can see I'm going to get, what, a half of 3 minus 4a. And then maybe multiply both sides by 2. I could have multiplied both sides. In fact, I probably did that. Multiply both sides by 2 at the same time, because then the 2's will cancel there, right? So I just get 3 minus 4a, and then here I'm going to get 2 times 4. So rather than doing it as 2 separate steps, maybe just do it in one go. There's 2 denominators, 2 and 3 minus 4. So I multiply both sides by both of them, all right? On the right-hand side, these will cancel. I get 2 times 4, which is 8, and 2 times 3a, which is 6a. And on the left-hand side, the 2's cancel. I'm going to get 1 times 3 minus 4, so I get 3 minus 4a like that. And now bring the 4a across here, I get 10a over on the right-hand side. And bring it across here, 3 minus 8 is minus 5. And then divide by 10, I get a is minus a half. That's my value for tan y. It's minus a half. Okay, so quite a lot in that lesson there, and messing around with those formulas. They're not that easy, not that intuitive to work with, but it's just a matter of you don't have to learn off or know what these formulas look like. They're in your formula booklet, so I'm trying to manipulate formulas like this. It's always worth opening up page 14, 15 in particular, and kind of seeing what formulas are there. So in the last couple of lessons on trigonometry, we're going to look at proving some of these formulas. We'll have a look at the next lesson at the required proofs that you can learn off for your exam. And then the final lesson, we'll be looking at proving ones you haven't seen before. So it's going to be proofs kind of from here until the end of the topic.